Hi guys, welcome back to Super Math for You. This is Mr. Urrego, and today we're reviewing the B.E.S.T end of course exam for Algebra 1. Before we start, let me show you the reference sheet that you are able to use the day of. I'll have a link on the description, as well other material. I have the links on the description. Now, make sure you check these two reviews. They're very helpful and very extensive, so they will be great and it will help you to review for this exam. Let's start. I'll put a link on the description for this site so you can practice this, the English and the history and the science and other stuff. First problem, dog has 8 square pieces of wood. Each piece of wood has a side length of s centimeters. The total area of all 8 pieces is 200 square centimeters. Create a quadratic equation dog can use to find the side length of each piece of wood. So first of all, let's get information. So 8 pieces of wood, each side is s, right? And these are squares. Squares, that means all the sides are equal, okay? And each side means measure s. He has 8 pieces in total and the area is 200. So first of all, let's do one piece. What's the area of one piece of wood? Is s times s. So the area for one piece is s squared. Now, how many pieces he has? He has 8. So it's 8 times this. So 8 times, so the total area is going to be a times the area of 1, which is s squared. And they're saying that 200 pieces, the 8 pieces is equal to 200 square centimeters. So the 8 pieces is equal to 200 square centimeters. What's my equation? A van, number 2. A van sells X premium tickets and Y regular tickets for a concert. The X is the premium, the Y is regular. A premium ticket costs 20. Premium, 20. A regular costs 5 less than the premium. So the regular 5 less is 15. The band raises this type of money from selling tickets. Select coefficients to complete the equation representing the relationship between X and Y. X is premium, Y is regular. X is premium. The premium is 20. Regular is Y, which is 5 less, equals, so the price times the number of tickets for premium, the price times the number of tickets for regular equals the total amount. Let's go next. Enter an expression to make a true equation. They give you x, y, and z, everything to the second power minus 1 equals, and I have parentheses, times another parenthesis. So here's a little trick, okay? If you notice, I have x, y, z to the second minus 1, and here's only 1. Why x, y, z minus 1? Without the square. Most people will write this again. They'll write x, y, z minus 1 here, right? Thinking that this is going to be to the second power. But if you multiply this is going to give you a different type of problem. It's going to be that minus 2 times x, y, z plus 1. Okay, and this will be the most common mistake. What we need to do is this. Let me pretend that I have a difference of squares, x squared minus y squared. This is to the second power minus 1 is also to the second power. 1 is a perfect square, cube, and so on. Why am I doing this? Because when I factor the difference of squares, this is going to be x plus y times x minus y. All right? And if you notice, I have x minus y already. I'm missing the x plus y. Again, this is the opposite of a difference of squares pattern. I have a difference of 2 squares. They're giving me the minus. I need to put the plus. So here I have x, y, z plus 1. And that's what I'm missing right there. when you multiply these two, you'll get this. Let's go to number 4. They give me the function 2x plus 1. Select all the effects on the graph of the function when f of x is multiplied by 3, when this function is times 3. So technically this is what I'm doing. My function times 3. So this means this times 3. Alright? When I multiply times 3, that's going to give me 6x, right? 3 times 2, and then plus 3. So when I multiply my original function, I get 6x plus 3. Now, according to this, what can I say? The x-intercept increases or decreases. To do this, I need to do the math. So how to find the x-intercept? First of all, let's find it from the original. Okay, I have f of x. If I'm looking for the x-intercept, that means I make my y. Remember, f of x is the same as y. Looking for the x-intercept, I make my y 0. From here, I need to find the value of x. Minus 1, minus 1. That means I have negative 1 equals to 2x divided by 2 divided by 2. And I'll get negative 1/2 is equal to my x-intercept. This is from my original function. I got to do the same thing. I got to do the same thing for my new function. So remember, let's call that g of x equals 6x plus 3. To find the x-intercept, I make this 0. 6x plus 3. Leave the x by itself, minus 3 on both sides, and I'll get 6x. And then divided by 6 and divided by 6. If I simplify 3 and 6, I'm going to get negative 1/2. Right? Divided by 6 cancel out, and this is going to be 1/2. Now, did the x-intercept change? It didn't. So the only two choices that I have here is increases or decreases, so I don't have to do any of them. Next, the y-intercept increases or decreases. Remember, my new function was g of x equals 6x plus 3. Let's find out about the y-intercept. Let's do the original one. So I have f of x. If I'm looking for the y-intercept, I make my x 0. So let's call this y, and this is going to be 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. So this is your y-intercept for the original function. Now if I'm looking for the new function, so we need to make the x 0. So let's call this y, and 6 times 0 plus 3, right? 6 times 0 is 0 plus 3 is 3. So if you notice, my y-intercept went from 1 to 3. Therefore, my y-intercept increased. What about the slope? Now the slope is, remember, for my original function, any number in front of the x. So my slope here is 2. And my new function is 6. So my slope went from 2 to 6. That means my slope increased. Next problem. The equation for the function f is shown. The quadratic function g has the following properties. Now, look at this. This is g, this is f. So this is a different function. They give you one function, and now that we're going to talk about the g function. G has a lesser value y-intercept than f. Good. The maximum value and y-intercept of g are not equal. First g increases and then it decreases. So let's understand. The g function is a quadratic. Remember, a quadratic function has two choices. Quadratic is a U shape, okay? Decreases and increases, and this is the minimum value. Now, it can also open down, meaning I can have this quadratic function, right? In my case, the maximum value and y-intercept of g are not equal. So they're talking about this one. This one is a maximum value, right? When my parabola is opening down, this is a maximum. If my parabola is opening up, this is a minimum value. Okay? We're talking about maximum. Therefore, we're not using this, we're using this function. First, g increases and then it decreases. Look, it increases, is going up, and then decreases. So this is the type of function that we're looking for, the quadratic. Excellent. Let's go back. So we take this, we take this. G has a lesser value y-intercept than f. So let's graph this first of all. Let's do this with blue. So this function has a 3 as a y-intercept, and now it has -1/2, so 1 down and 2 to the right. Remember, slope is rise over run. Let's put this negative to the top. 1 down and 2 to the right. So my line goes something like this. Okay? All right. Now, my g function has a lesser y-intercept than f, meaning my y-intercept is going to be lower at any point over here, any point. So my y-intercept is this. Maximum value and y-intercept of g are not equal. Has a lesser y-intercept, so I grab this, and we can put it anywhere we want. This is less, right? Anywhere we want. And the maximum and y-intercept of g are not equal. So my vertex is the maximum value, right? We said that this vertex is the maximum. We just put it somewhere up there. All right, the y-intercept is less, and these two are not equal. Now when my graph goes, it's going to go up and it goes down, right? According to this graph. Let's go next. The expression can be used to model the sales in dollars of a company after m months. The value 12 was substituted for m to create the expression. What's m? Months. Enter a number and select a unit to complete the sentence. The expression represents the growth factor of the company's sales for a period of time lasting. So m is 12 months. Next. A table of values for a linear function is shown. This is a linear. Match each key feature of the graph to its value. X-intercept, y-intercept, rate of change. Rate of change is the same as slope. Okay? So my slope is y2 minus y1, x2 minus x1. That's something that we can do right away. We can use any 2 points. Let's use these 2 points. So this is x1, y1, x2, y2. My slope is 6 minus 0 over 6 minus 3. 6 divided by 3, give me 2. Rate of change, 2. X-intercept, y-intercept. How do I know this? I have, remember, f of x is the same as y. How do I look for the x-intercept or the y-intercept? I make the other one 0. So if the y is 0, that means this 3 is an x-intercept, right? If the y is 0, then this value is for my x-intercept. X-intercept is, and I have 2 values. The last value is the y-intercept, okay? For the y-intercept, there's a couple ways how do we do it. First, we can go back and write the equation in slope-intercept form. We have the slope, okay? We don't have the y-intercept. So we can find the y-intercept like this. So we can use one of these points. Let's use 3, 0. This is the x and this is the y. And I'm going to plug it back in here. So the y is 0. M is 2, right? The slope times the x, which is the 3, plus b. And now we need to solve for b. Multiply that, subtract here both sides, and 0 minus 6 gives you -6. Cancel, and my y-intercept is -6. And we had the 3 information that they asked me. Next problem. The fuel economy of a car is its average distance traveled per amount of fuel consumed. Cars have different fuel economies when they're driven on the city and on the highway. A linear model of the relationship between the city and the highway fuel economies of 8 cars in miles per gallon is shown. All right. So they gave me this. Which linear equation best models the scatter plot? Right? Because all of these points are not in a straight line. What's going to happen is this is called a scatter plot. And I need to find the line of best fit. Line of best fit is the line that goes in between all those points, right? Something like that. So what's the idea? I have the line of best fit. If you notice, I have like 2 or 3 points below and a couple points above, and my line is going through most of the points. So for this, I'll be using the coordinates of any 2 points, right? I can use that one, I can use that one, I can use that one. Let's use that to find the equation of the line. So let's use this for example, and this is going to be 33, 41. And also I'm going to use, let's say this is 36, 43. As soon as I have 2 points, now I can find the equation of the line. The first thing that I need to do is to find the slope. We did it in the previous problem, y2 minus y1 over x2 minus x1. All right. x1, y1, x2, y2, label. Don't make mistakes because you didn't label. So 43 minus 41 divided by 36 minus 33. This gives you 2 on the top and this gives you 3 on the bottom, and it's positive because my line is going up from left to right. Okay, once you have the slope, you use the slope and one of those points to plug it back in. Let's use this point and let's use the slope. So y is 41. My slope is 2/3. Be careful, you multiply times the x, and the x is 33 plus b. Okay, and the only variable here that you have to solve is for b. Now let's make this a fraction and let's keep going. 41 is equal to, how do I multiply fractions? Top with top, which is going to give me 66 over 3 plus b. Then you simplify, and let me keep 41 here. 66 divided by 3 is going to give me 22 plus b, and now minus 22 on both sides, and this is going to give me 19 equals to b, which is my y-intercept. So now your equation is y equals mx plus b. Y equals m, which is 2/3 of x plus 19. That's your answer. Be careful, they're trying to trick you over here when they flip the slope. All right, there's 2 parts of this problem. Let's do part B. Based on the model in part A, what could be the highway fuel economy in miles per gallon of a car that has a city fuel economy of 43 miles per gallon? Right, your answer to me is 100. Highway is the y, city is the x. So they're asking me for the y. Okay, when the city, which is the x, right, city is the x, is 43, so you just need to plug that in. So y equals 2/3 of x, but x is 43, plus 19. Plug this into the calculator. And they're saying to round it to 100, meaning 2 decimal places. So it'd be 47, 66. No, that goes higher one. So 47.67. It goes. And we're done. Next. Question 9. Giselle has 40 prizes for raffle ticket winners. She gives away 2 prizes each day until she runs out of prizes. The equation p plus 2t equals 40 represents the situation where p is the number of prizes Giselle has left after t days. So if you notice, 2 prizes each day, this is my slope. When they say 2 prizes per day, per hour, per minute, per something, okay, so 2 is my slope, therefore this is your x, your dependent variable. So let's go, let's scroll up. Part A, first select p or t to represent the independent variable. Now, every time you have an equation, y equals mx plus b, right? Remember when you graph this, this is your x and this is your y, right? Your x is your independent. When you do the table of values, right, you put the values of x. You put 1, 2, and 3, right? You put the x values. These are your independent. The y is dependent on the values of x, so independent, and the y is dependent. So first select P or Q to represent the independent variable. In my case is the x. So here we can leave the P by itself, minus 2t minus 2t, and that's going to give me P equals negative 2t plus 40. You see, similar to mx plus b, where t is your x, therefore t is your independent variable. Okay. Then use the add arrow tool to graph the relationship. Okay, my relationship, I need to graph this. So my y-intercept is 40, that's fine. Here we go, let's get points. Where's this? Add a point. So this is 1 point, 40. Now, because the values are big, 10, 20, 30, 40, and on the x and the y, and your slope is really small, negative 2, it's kind of confusing to graph using the slope here. So what you want to do is you want to do the y-intercept and the x-intercept. Remember, this is your t-intercept and this is your p-intercept. You have your p-intercept, which is 40, right? That's the same as the y. And now my t-intercept is the same as the x. If I want to find the t-intercept, I make the other one 0. So let's make the p 0 and let's find the value of t. So plus minus 40 minus 40, that's going to give me negative 40 equal to negative 2t divided by negative 2, and that's going to give me 20. So my t-intercept is going to be 20. Let's mark it. 0.20. And now I need to draw a line, right? Use the arrow. Okay, so here we go. Where's the arrow? Here's the arrow. And let's make an arrow from those 2 points. And that's going to be my graph. Let's go with part B. Enter a value in each box to describe the relationship. Okay, the domain of the relationship is from, alright, what's my domain? The x values. Where's my graph starting? Look, it started here. At this point, how much is the x value? 0. And what's the highest value on my x-axis? 20. So it goes from 0 to 20. That's my domain. 20. And Giselle will give away all the prizes after how many days? Right? Remember, this is t. This is the number of days. That's 20. When she has 20 days, P is the amount of prizes. So here at 20, she'll have 0 prizes. Giselle will give away all the prizes after 20 days. And we're done with this. Next, number 10. A school office surveys 6th and 7th grade students about whether they ride to the bus to school. The data are recorded in a frequency table. This is my frequency table. Enter numbers to complete the frequency table for the data. Alright, so what happens about this table is horizontally, they need to add up to this total. Horizontal to this total. Horizontal to this total. Now vertically, you add these two and you get this. You add these two and you get this. You add these two and you get this. So you start where you get the most information. Right now I have these two, I can find the third side, right? The third value. So 176 plus 74, right? That's going to give me 0. This is going to be 14 and 1 is 15, and this is going to be 2. So this is 250. All right? I don't have anything here. I have 2 values here. I can find either this value or let's find this one over here. So 250 plus what value gives me 400? So 400 minus 250 is 150. All right. Now next, what value plus 128 gives me 400? So 400 minus 128 will give me this value. This is 2. This turns into a 9. 9 minus 2 is 7. This turns into a 3. 3 minus 1 is 2. So 272. Let's double check. 2 and 8 is 10. I carry 1, 7, 8, 10. All right. Now I have 2 values here and I have 2 values here, so I can find the middle value. So 176 plus what gives me 272? Or I subtract 272 minus 176. 272 minus 176. All right, this is 6. And this turns into 6. And this turns into 1. And this turns into 16. 16 minus 7 is 9. And subtract, you get 96. Same idea here. 74 plus what gives you 128. So 128 minus 74. This is 4, and 12 minus 7 is 5. Now, if I add horizontally, I get 250. If I add these two, I get 150. 96 and 54 is 150. 272 in this is 400. And going down gives me this answer. This 2 gives me this answer. This 2 gives me this answer. That's the way to triple check all those. Next problem. A system inequality is number 11. A system inequality is shown. I have two inequalities. Select a solid or dotted line, boundary line for each inequality. Click in the region to graph the solution set. Now, in inequality, you draw the same thing that you draw a regular line. This is your slope, this is your y-intercept. Y-intercept, any point is in the slope. Okay? You have two inequalities. Inequality 1, because it doesn't have an equal sign, then my line will be dotted or dash. If it has an equal, like number 2, it will be solid. So my inequality first is dotted. Click. Oh, it drew the line for me. Very nice, thank you. If you notice, look at my y-intercept, -1, and my slope is -1, right? -1 over 1, so 1 down, 1 to the right. Now, how do I know where's my shade? You see that? Graph the solution set. Solution set is the shade. So I need to know if it's above or below. So let's graph the second one and then we choose. Second one, y is greater or equal to x plus 1. Greater than or equal, so it's solid. And that's my second line. All right, now let's do something. When you're shading, if the y and it has less than, y is less than, that means this is the y. Then that means my shade is below the line. Y less than is below. And here, y is greater, that means is a solid line and is above. So y greater is above. Greater is above. Now you tell me in where, out of those intersections, where is your graph intersecting the two shades? Here I only have one graph, here I have two, and here I have one. So here in this corner is intersecting. Therefore, click in the region to select the graph. So here's where they're intersecting. Okay? That's how you know the intersection of the shades. Next one. Number 12. The table shown represents two functions, function A and function B. They give you a table, okay, two functions. Let's go to the questions and see what we need to do. Complete the sentences to compare the two functions. Function A appears to grow linearly or exponentially. Oh, it gives you only two choices. That's not too bad. Function B appears to grow linearly or exponential. Okay. As x increases, the quantities for function A or B will eventually exceed the quantities for. All right, so you got to compare them. So the first question is it linear or exponential? Now, linear is easy. We just need to find the slope. Exponentially is the common ratio. So when we're doing linear functions is called the common difference, which is basically finding the slope. Exponential is called the common ratio, which is dividing. But if we do linear and if the function is linear, then there's no need to find exponential. Now, because here they only give you two choices, is very simple. Let me explain. Let's do A. Let's find the slope. y2 minus y1 over x2 minus x1. All right? So let's use these 2 points first. This is x and this is y, right? So this is x1, y1, x2, y2. So 750 minus 700, I'm sorry, and this is 1 minus 0. 750 minus 700 is 50, divided by 1 is 50. So my slope is 50 using the first two. In order to be linear, my slope has to be constant. All right, so let's do these two for example. x1, y1, x2, y2. So y2 is 1200 minus 750. 1200 minus 750 is 2 is 450. 10 minus 1 is 9. 45 divided by 9 is 5, and then I add the 0. If you notice, my slope is the same. If my slope is constant, we got to do the third one just to double check. Right now I'm using the last 2 points. So it's y2, which is 1700 minus 1200, divided by 20 minus 10, and now 1700 minus 1200 is 500, divided by 10, you cancel a 0, you cancel a 0, and my slope is 50. So if my slope is constant, that means function A is linear. All right? This will be the process that I have to do with function B. Let's go with B. Let's use the first 2 points. So I'm going to use, let's cross this A so we don't make mistakes with A. So x1, y1, x2, y2. So 624 minus 600 is 24 over 1. So this is the slope. Let's use next 2 points. So it's 80, 88. If you notice, they have an asterisk saying rounded value, so they rounded here. This was decimals, and now they rounded. Okay, and we subtract this. Let's use a calculator. So it's divided by 9. If you notice, the slope is different. That means function B right there is not linear, because I'm only getting 2 choices. The decision is simple. If it's not linear, it's exponential, right? So this is simple. I can go with explaining the exponential, but right now, no need for that because it's really confusing. So, because this is not linear, it has to be exponential. And function A, you know, we knew that it was linear, okay? Now, as x increases, the quantities for function A or B will eventually exceed. Exceed will be, means greater. So which one will be greater than the other one as the x increases? So let's erase this. Let's read number 13. In a survey of 3,260 people, 57% of people said that they spend more than 2 hours a day on their smartphones. The margin of error is 2.2 plus or minus 2.2%. The survey is used to estimate the number of people in a town of 17,247 who spend more than 2 hours a day on their smartphones. All right. Based on the survey, what are these estimated minimum and maximum number of people in the town who spend more than 2 hours a day on their smartphones? Write your answer to the nearest whole number. So the idea is they give you a minimum or maximum. Why a minimum or maximum and not just one value? Because they have a margin of error. Meaning they're going to do 57% plus 2.2%. But also 57% minus 2.2%. All right, so that's the math that we need to do. So to get my minimum, I'll have 57% minus 2.2%. To get my maximum, I'll have 57% plus 2.2%. 57 minus 2 is 55, minus 0.2 is 54.8%. All right, I think this math is better. And here, 57 and 2 is 59.2. So this will give me my minimum, this will give me a maximum. Now I got to find these percentages of this amount of people. So 54.8% of this. Let's do that on the calculator. First of all, 54.8%. How do I do percentage as a decimal? I got to divide by 100. And now my percentage turns into a decimal. Now this times the value, which is 17,000, so times 17,247, which is the population of, that's 9451, okay? So we'll run that in a minute. We need to type it here. That will be my minimum, and my maximum is going to be 59.2%. Is percentage. I need as a decimal. I need to divide by 100. That's going to give me a decimal times the amount of people, which it was 17,247, times 17,247 equals, and I have 10, 12, 10.2. Now the problem here is the following. Can I have 0.2 people? No. So when they say rounded, because we're talking about people, for the most part we need to round it to a whole number. So 10,211. Can we round down? Not really, because we're talking about people. So this will be 10,211 11. Okay, so let's go here and let's type those values. Round your answers to nearest whole numbers. Okay, and with this we finished this one. Let me see, I think this is the last problem. Yes, so we need to end the test. Please like the video if you learned something today. Make sure you practice. I'm linking the library for the EOC. I have 2 full exams right there that you can practice. Make sure you go over them, all right? The strategies that I explained. Like the video, please. Subscribe to the channel. Again, thank you for watching, and I'll see you in the next one. Take care. Bye-bye.